Hi everyone, so in this video we will study about MOS amplifier with the body effect. Okay, so generally what do we see? We see these kind of circuitry in MOS amplifiers. There is no body effect, no body terminal. They don't even discuss about body terminal. In all the question you will see there is written consider body effect to be neglected. So there is no body effect. But in 2021 biomedical question paper this question was asked. Here they are considering the body effect. Here this is the input applied V in. That is applied at the body terminal, not at source, not at drain, not at gate. It's at body. So how to tackle these kind of questions? So we will see the complete concept from zero to complete advanced. Okay, and within 1 minute you will be able to solve the question. Okay, within 1 minute, only 2 lines will be there which will help you to solve the problem. So let's see what is the general idea that we have studied. We have studied these kind of circuit. So in this kind of circuit, what is the small signal current? So we can simply make our circuit, make our MOS. So this will be our MOS. What will be this current? This current would be GM into VGS. Gate voltage minus source voltage. Small signal VGS. Okay, and there will be one R not connected, right? And the direction of current would have been from drain to source, and this being gate. This is what we have studied. And in case of PMOS, what we have studied? In case of PMOS, this we have already seen, right? In case of PMOS, the current will be GM VSG. GM VSG. And the direction of the current will be from source to drain. Right? This we have already seen a lot of time. Right? This will be VG. Okay. So this we have already seen. Now, first tell me what kind of MOS is that? It is NMOS or PMOS? I hope you are comfortable with the sign convention. Okay. So this is known as NMOS. When the arrow is inward. So this is NMOS and this is PMOS. The arrow will be towards body terminal, that means it is PMOS, and if arrow is inward, that means it is NMOS. How it is written? Let's make a structure of NMOS. So this is your NMOS, right? And this is P type. This is your body. Okay. So if this is N, this is P. So how will you make it? Like this, right? N negative, P positive. So this is how you will make a diode. So in this diode, what is the sign of arrow? Like this, going out of the body terminal. This is how you will make a diode, right? Going out of the body terminal. In case of PMOS, what will happen? This will be of N type, and here we will have P plus. So diode will be something like this, right? So, and this will be body. So arrow will be coming into the body terminal. So arrow will be like this. So that's why we show like this and like this. Got my point? So this is NMOS, this is our PMOS. Now, mostly it is assumed that body and source are tied together in a MOS circuit. So when body and source are tied together, that means VBS or VSB, you can say, that will be 0 volt. So in all those questions that we already see in these kind of circuits, in these kind of circuit, it is assumed that body and source are tied together. That means VSB is 0. Both potential are connected together. So VSB is 0. Then we can replace the circuit something like this. Then we will not talk about body terminal. Okay. And this is source. So we will not talk about body terminal. Okay. Now, what if our VSB is not 0? What if our VSB is not 0? Then we will see a small signal circuit of our MOSFET. So initially, what was our MOSFET? Simply a GM VSG current was flowing. Okay, the current that was flowing was GM. In case of PMOS, it was GM VGS, right? GM VGS. Now the current will be GM VGS plus GMB transconductance for body, okay, GMB into VBS. This G will be replaced with B. So the current that will be flowing is GMVGS plus GMB VBS. That's it. No other change will be there. That's it. So initially, how we used to draw the model? We will draw the model in the same way only. How we used to draw? We used to draw something like this, right? And here we show a resistance, and then this had been our R naught, right? This had been our source. This had been our, sorry, not source. Okay, let's forget about this model. This will needlessly create pressure on you. We don't need to think about that model. We can only think about that current model that we draw. Okay, because I don't want you to study a lot of things. Just I want you to solve the problem if they ask you, right? So this will be our gate. We are drawing small signal model. This will be our drain. This will be our source, and this is our body, right? Now there will be an R naught connected. There will be no change in R naught. R naught will be the same as it is. Now previously what did we show? The current is GM VGS. Now what will be the current? The current will be GM VGS plus plus GMB VBS. That's it. GM VGS plus GMB VBS. So what will be VBS? VBS will be VB minus VS. Okay, so this was for NMOS. Are you getting my point? It is the same, just there is a component of current is also added. Small signal component of current is also added. That's it. What was our GM? GM was del ID upon del VGS, right? This was a large signal parameter, GM, del ID upon del VGS. Similarly, what will be our GMB? GMB will be del ID upon del VBS. Are you getting my point? Our GM was del ID upon del VGS. Similarly, our GMB will be del ID upon del VBS. Okay. So simply G will be replaced with B, and so same analysis will be there. Just a component of current is added. That's it. What will happen in case of PMOS? In case of PMOS, what will happen? The same circuitry, nothing different. Okay, R naught will be there. Nothing different, same, everything is same. This is drain, this is gate, this is source, and this is body. Now just tell about the current. The current was GM VSG, right? GM VSG, source minus gate, plus GMB VSB. G will be replaced with V only. So the current is increased. Current is GM VSG plus GMB VSB. Now if source and body were tied together, then VSB would have been 0. So this component would not come, right? We will see the examples. If source and body were tied together, source and body were tied together. If they were tied together, that means VSB would have been 0. Got my point? And then your current would have been, this component would have been 0 only, right? Okay, just a small change here. This arrow is wrong. This arrow is wrong here. This arrow is also wrong. The arrow would have been outward, right? So that's what I was thinking. What is wrong there? Arrow would have been outward. In case of PMOS, arrow would have been outward, right? So yeah, what you need to see, only there is one thing, that is the current was GM VSG first. Now the current is increased to GM VSG plus GMB VSB. That's it. Okay. Now there is one point to note, that is very important point. When there is nothing mentioned about the bulk potential, then it is considered to be connected to ground. Let's assume they have given some question. They don't talk about body potential there. Okay. They are not talking whether it is connected to source or drain or anywhere. That means it will be considered to be connected to ground. Let's assume in a question this is given. In a question this is given. The source potential, drain potential, everything they have talked about. Drain, what I am doing, this is gate, this is source. They have talked about everything. Okay. Now they haven't talked about this body terminal. So where it will be connected? It will be connected to the ground. It's not necessary that it will be connected to the source. Okay. It's not necessary that it will be connected to the source. It will be connected to the ground. Connected to the ground, not with source. Not with source. Okay. So let's see the analysis one by one. We will see the analysis of common source amplifier and common gate amplifier. For common drain amplifier, you can do by your own. Okay. Actually, very rarely it is asked, but since it is asked in biomedical gate 2021 question paper, that's why I am dealing this concept here. Okay. So it can be asked anytime in EC or instrumentation. So let's see the analysis of common source amplifier. So this, for this amplifier, GM, GMB are not, everything is given. Okay. Did they talk about base potential? Sorry, body potential. Did they talk about body potential? No, they did not talk about body potential. That means the body will be connected to ground only. So here, this is V in, this is source that is connected to ground, this is body terminal which will also be connected to ground, and this is VDD, this will also be connected to ground. Okay, and then we are having a R0 here. There is an issue, sorry, this will be V0, not VDD. This will be V0 here, right? So this is your V0, not VDD. So this is the V0, and from V0 to ground we are having a R0. From V0 to source we are having a R0, but source is also grounded, so here it is also 0. Now tell me, what will be the current? What will be the current ID? Current ID would be GM VGS. Since this is an PMOS, so it will be GM VGS plus GMB VBS. So GM, what is the potential of gate voltage? That is V in. What is the potential of source voltage? That is 0. Plus GMB, what is the potential of base voltage? Sorry, body. I mistakenly say body as base sometimes. Okay, so if I am saying base, please consider it to be body. Okay, sometimes it happens with me. So what is the potential of body now? Body is grounded, right? So it will be 0. Source is also grounded, it will be 0 only. So what is the current now? GMV in only. In case of common source amplifier, there is no effect of GMV. Did you understand it? Because the body is already connected to ground and source is also connected to ground. So your VBS is eventually becoming 0 only. Okay, but it will take action when we talk about common gate amplifier. So we will talk about that. But here your ID is GM V in only. So what will be your R V0? V0 will be GM V in into R0 minus sign will be there, because the current will be flowing like this. So sign will be negative. Okay, so V0 by V in would be minus GM R0. So anytime it may come in gate examination. Okay, so you should be understanding this concept. So let's move on to the next problem. So we will see common gate amplifier now. Okay, so in this common gate amplifier, your gate is grounded. Now we haven't talked about this body terminal, so we will consider this to be grounded. Now tell me, what will be your ID? What will be your ID? Although I will make a model. Okay, we will make the model later on. So first tell me what will be your ID. So we know what is ID in case of NMOS, that is GM VGS plus GMB VBS, right? So it will be GM. What is VGS? Tell me, what is VGS? VGS is 0 minus VI plus GMB. Tell me, what is VBS? VBS, body is at 0 minus source is at V in now. I told you, if they are not talking about the body terminal, that means it is connected to ground, not to the source. If you connect it to the source, that means VBS will be 0. So if they are not talking about the body terminal, that means it is connected to the ground. Okay. So the current is minus GM plus GMB VI. The current will be in upward direction, right? So basically this will be our model. Now I can simply replace it with the MOS only. NMOS, simple NMOS I am drawing. It's okay, sorry. This is our V in. This is grounded. This is R0. So R0 will be connected between drain and source. That means between V0 and V in. So R0 will be connected at AR. between V naught and V in. This is our R naught. So V in will be here. Basically, between V naught and V in, I am connecting R naught. This I have already told all these things in previous lectures. How to connect R naught, all these things. So between V naught and V in, I am connecting R naught, and this is our ground. What is the current flowing? ID current was flowing in the downward direction, but negative sign was there. So in upward direction, this much current is flowing. That is GM plus GMB V in. Okay. So what will be your V naught? V naught. Tell me what will be your V naught. So because of this current, the drop will be in this direction. So can I write my V naught as V in plus GM plus GMB R naught into V in. Did you guys understand this point? My current is flowing GM plus GMB into V in. That means that much of current is flowing in this direction. So what will be this drop? This drop will be current. What is the value of current? That is GM plus GMB V in into the resistance, that will be R naught. And what will be V naught? V naught will be this potential plus this potential. This potential is V in plus this potential is GM plus GMB R naught into V in. So this is how you wrote your V naught. Got this point? Otherwise, you can do your circuit analysis as well, but you should be able to write it quickly. All these things you should be able to write it quickly. What we did, we just found the current. Then we saw here we have V in. The current is flowing in the R naught resistance. And since the current is flowing in the R naught resistance, that means the drop it will give is current into the resistance R naught. So current is GM plus GMB into V in into the resistance R naught. So what will be our V naught? V naught will be V in plus this drop. V in plus GM plus GMB V in into R naught. So basically V naught by V in would be 1 plus GM plus GMB R naught. Are you getting my point? So this is how we are doing the analysis. Now you can do the analysis for common drain amplifier as well in the similar manner. Although this is not very important, that's why I am not doing the common drain analysis here. Now we will be solving the questions, how it is asked in the examination. So this question is given in front of you. They asked you to find the value of V naught by V in. The circuit is given. This is a PMOS given. For PMOS, these parameters are given GM, GMB and R naught. They asked you to find V naught by V in. Okay, we will do the simple analysis that I have told you. From that analysis only we have solved every single question of MOS amplifier, right? Every single question we solved from the single analysis. Okay. So tell me, first we will find the value of ID. What will be the current? ID. ID will be GM VSG, right? In case of PMOS, it is GM VSG plus GMB VSB, right? Tell me, what will be GM VSG? Source is connected to V in. Source is connected to V in. And gate is also connected to V in plus GMB VSB. Source is connected to V in. Where is body connected? Look, it's not necessary that they will always give something like this. They will not give this line. It's not necessary. They will give this line. It's not necessary. You have to consider by your own. Okay. So since they are talking about GMB, that means some body terminal is there, but they haven't talked about it. That means it is grounded. What do I mean to say? If they have given GMB, that means body effect is there. Body effect is there. Okay. They have given GMB, that means body effect is there. Now, what is body effect? You don't need to think about it. Okay. In device physics, we will learn what is body effect. Here we are just seeing the circuit analysis. So if they have given the value of GMB, that means body effect is there. Okay. Now they haven't talked about the body terminal. If they haven't talked about the body terminal, that means the body terminal is grounded. So basically your body terminal is grounded. That means the value of VB is 0. Value of VB is 0. So simply the current is GMB VI. That's it. So the current flowing is GMB VI. So now you can draw the model. If GMB was not given, the answer would have been very simple for us. There will be no current. The gain would be 0 or the 1. The gain would be 0 or 1. The gain would be 1 actually. If GMB was not given, the gain would be 0 or 1. The gain would be 1. Why so? You can see here now. Look. This is your V in and this is your V naught. Between V in and V naught, there will be R naught connected. There will be R naught connected, and this will be your V naught. Now this current is flowing in this direction. ID current is flowing. That current ID is GMB VI. Right? So V in plus GMB R naught VI is equals to V naught. Are you guys able to understand this point? V in plus GMB R naught into VI is equals to V naught. Because this current is flowing in this direction, ID current is flowing, ID current value is GMB VI, GMB VI. In R naught, it is upward. In the MOS, it is flowing in this direction, but in R naught, it is upward. So basically, GMB VI current is flowing upward. That means the drop will be like this, right? If the drop is like this, that means this voltage drop will be GMB VI into R naught, right? So V in plus this drop is equals to V naught. So V in plus GMB R naught VI is equals to V naught. So V naught by V in would be 1 plus GMB R naught. Okay. And if this GMB was not given, only the question was GM and R naught is given, then what will be the gain? Gain will be 1. Why so? Because this current will be 0, then simply V naught will be equals to V naught. V naught will be equals to V in. If the current is 0, that means there will be no voltage drop across this resistance, that means V naught will be equals to V in. If GMB was 0, that means if GMB was not given, that means V naught is equals to V in, so gain would have been 1. But since GMB is given, the gain is 1 plus GMB R naught. Well and good. Let's move on to the next problem. Here you need to find the voltage gain, small signal voltage gain V naught by V in. Okay. So everything is given for this as well. GM2, GMB R naught is given. This as well. GM1, GMB1. Here GMB2 I should write. GMB2 R naught 2 is given. GMB1 R naught 1 is given. Okay. Yeah. So let's see. Let's see the analysis. Now there are two MOS. So let's see the analysis. What will happen to this one? Let's check that. So here VDD is connected. This is V in. This is V naught. Now for the lower one, this VDD will be grounded, right? Because this is a DC bias. This will be grounded. This M1 will, this is already grounded. Now they are not talking about the base terminal, sorry, body terminal. They are not talking about the body terminal. That means it is always considered to be grounded. So tell me what will be the current here? And there will be this R naught connected as well, R naught 1. So I should make, and this VDD will also be grounded. This VDD will also be grounded. Okay. So R naught 1 will be connected here. This will be R naught 2 actually. This will be R naught 2 and one R naught 1 will be connected here. Right. So from V naught to ground we can see R naught 2 and R naught 1. Tell me what will be the current here in this branch? What will be the current? That would be GM VGS. GM VGS. VGS is 0. The current would be GM VGS plus GMB VS VGS yaar. VGS. GM VGS plus GMB VBS. VGS is 0. Gate and source both are 0. That means this will be 0. Plus, what about VBS? Base is at 0, source is at 0. That means this is also 0. So, 0 current. No current is flowing. So, simply this will be open circuited. Are you getting my point? So, there will be 0 ampere current. No source small signal current is there. This will be 0 ampere. Right? So, basically how we can reduce our circuit now? Our circuit can be reduced something like this. This is V in. This is grounded. This is R naught 1 parallel with R naught 2. This is our V naught. Okay. This is ground. Now they haven't talked about the body terminal of this. So this will also be grounded. Right. This is V in. This is V naught. Well and good. Now tell me what will be the current in this direction? Okay. Not in this direction. ID current will be downward. This will be our ID current. So tell me what will be the value of ID current? that would be GM VGS. VGS. What is VGS? V in minus V naught plus GMB VBS. GMB VBS. What is the potential of base? Sorry, what is the potential of body? That is 0 because they haven't talked about it. Minus what is the potential of source? That is V naught. So our ID is GM. Why I am writing plus here? I don't know, man. That would be minus GM VGS. V in minus V naught and GMB VGS. So GM V in minus GM V naught minus GMB V naught. Tell me what will be your final V naught? V naught will be ID into R naught 1 parallel with R naught 2. Not 1 parallel with R naught 2. So what is the value of ID? That is GMVI minus GM plus GMB V naught. GM plus GMB V naught. That is ID. And then R naught 1 parallel with R naught 2. And that is V naught. So here you can take this term this side. GM plus GMB into R naught 1 parallel with R naught 2 into V naught is equals to GM. Which GM we are talking about? GM1 or GM2? GM2 we are talking about. Okay, so all these are GM2. GM2. For this it is GM2, right? So GM2, 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 GM2 R naught 1 parallel with R naught 2 VI. Okay, so your final answer would have been V naught by VI. GM2 R naught 1 parallel with R naught 2 upon, here you can take V naught common, so it would be 1 upon 1 plus GM2 plus GMB R naught 1 parallel with R naught 2. This would have been our final answer. So this is how you need to solve every problem. Are you getting my point? What did I do there? Here nothing, simple same analysis. They haven't talked about body terminal, both are grounded. Okay. Then I check the current here. The current here is 0. GM VGS is also 0 and GM VBS is also 0. Both are 0. So there is 0 current. That means this will be simply open circuited, but it will be replaced with our R01 resistance. And since this VDD is also grounded, so from V0 to ground I can see R01 parallel with R02. Now in this as well they also did not talk about body terminal. That means it will be considered 0 only. So here I can see GM2 V in minus V0 plus GMB 0 minus V0, because GM2 VGS is V in minus V0 plus GMB VBS base is also 0 minus V0. So this is the total current. Then simply I applied network analysis. By network analysis, V0 is ID into R01 parallel with R02. ID value I knew. From there I could find the value of V0 by V in. That's it. That's the final answer. Now let's solve the problem which was asked in GATE exam. Okay, it was asked in biomedical question paper, not in EC electrical or instrumentation. Okay, very good problem it is. So let's check that. So this circuit is given to you. You have to find the small signal voltage gain. Okay, they are talking about the DC gain. DC gain. If they are talking about DC gain is small signal voltage gain only. Okay, by DC they mean very less frequency. Okay, they are talking about small signal gain only. Okay, low frequency gain they are talking about, and low frequency that means you would make capacitor to be open circuited. Okay, so DC gain means small signal gain only. So here for finding DC gain we have to do the DC analysis. So we have to do the DC analysis now. So we have to find the small signal AC gain, small signal gain that I need to find. So I have to do the AC analysis, right? So I will do the AC analysis. If I do the AC analysis of this circuit, tell me one thing, what will be the potential here? That will be 0.9 volt. This is a DC value, right? This is also a DC value. This is also a DC value. And here you are having 1.8 volt. This is also a DC value. So what will be your AC equivalent? That will be This is DC value, that means this will be grounded. This is 1 kilo ohm. This will be your V naught. Here 0.9 volt you are having, that is also a DC point. So this is grounded. Or you can say this 1.8 will be grounded. So if you are having 0 here, 0 also will be there, right? If you are having 0 here, the potential here will also be 0. This is grounded and this is already grounded. Okay. Now here at base potential, you have applied V in plus this DC. So this will also be 0. This will also go to 0 volt. This will also go to 0 volt. And this will also go to 0 volt. All of them will go to 0 volt. So this will be your final circuit, right? AC signal, AC model. Small signal model you can say, or AC model you can say. So I will write AC model. Now tell me one thing. I guess I can copy this circuit on the next page. Or I can simply draw only. And what kind of MOS is that? NMOS, right? So this is NMOS. So tell me what will be the current? Current will be current ID. Current ID would be GM VGS plus GMB VBS. So GM, what is VGS? Gate and source both are 0. At gate 0 potential, source 0 potential, 0. Plus GMB VBS. At gate you are having, sorry, at body you are having V in. This is small signal input voltage that you are having V in. Minus at source you are having 0. So your ID is GMB V in. So here you are having GMB V in current, right? So what will be your V naught? V naught will be, this will be your current. So the drop will be in this direction. So V naught will be minus GMB V in into 1 kilo ohm. In the question they have given R naught is infinity. In somewhere it was given, as far as I remember, the threshold voltage is this, GMB by GM ratio they have given, volt terminal is small signal output voltage, that is in neglect channel length modulation. Okay, it is given that neglect channel length modulation. That means R naught is, that means R naught is infinity. Okay, yeah. So that is our gain. Now you don't have the value of GMB, right? So that will be our gain. So but you need to find the value of GMB. What is given? Given there is that GMB by GM is 0.1. This is given. It is given that the body effect transconductance GMB to GM is 0.1. Now you just need to find the value of GM. That you need to find. So how can you find the value of GM? So what is GM? What is GM? GM is mu n COX W by L VGS minus VT. This is the formula of GM, right? ID formula you know. ID formula is mu n COX W by 2L VGS minus VT whole square. Just differentiate it with respect to VGS. So what you will get? Mu n COX W by L VGS minus VT. Okay. This is given. Mu n COX is given. W by L is also given. VGS you can find. So this is DC parameter, right? GM is a DC parameter. I again and again say this thing. GM is a DC parameter. So you are doing that DC analysis here. GM is a DC parameter. So you are doing the DC analysis here. Okay. So by DC analysis, you can find the value of VGS. What is the value of VGS? That will be 0.9 volt. By DC analysis, you can find the value of VGS, right? What is the value of VGS? What is the value of VGS? If this is 1.8, that means this point will be 0.9, right? So 0.9 minus 0. So VGS value is 0.9. So here you can say VGS value is 0.9 and VT value given is, VT value is given as 0.4 as far as I remember. Yeah, 0.4. Now there is one thing. Okay. Actually this VT value is VT naught plus gamma root 2 phi f plus mod of v sb minus root 2 phi f. Okay, this is the expression of vt value actually, but they did not talk about this 2 phi f and all these things. We don't have any value of 2 phi f and gamma. We don't have that value. We have the value of mod of vsb. What is the value of mod of vsb? Tell me. What is the value of mod of vsb? You need to tell me this thing. Is it v in plus 0.5? Yeah, ideally it is v in plus 0.25 only, but v in is a small signal voltage. But here we are doing the DC analysis. We are doing the DC analysis. So only this 0.5 will come. Okay. So what is the value of mod of VSB? That is 0.5 volt. Got my point? So here we would put VT node is 0.4 plus gamma. Gamma value we don't have. Then we would have put the value of 2 phi f. Phi f is a work function here. Then we would put the value of VSB, that is 0.25, and then we would calculate the value of VT. But they did not give the value of gamma and phi f, and 99.9999% chance is there that they will never give this value. Okay, because the problem will become very complex now if they give these kind of values. Okay, so VT value they have already given 0.4. We will put that value only here. So what is GM? What is the value of mu n CUX? Mu n CUX is 200 micro. 200 micro into W by L. What will be W by L? W by L will be 40. What will be your VGS? VGS is 0.9 minus VT will be 0.4. So this is your GM. What will be your GMB? GMB will be 0.1 of this value. 0.1 into GM. That would be. And what is the unit of GM? That is Maho. Okay. So 0.1 micro. So it will be 20 into 40 into 10 to the power minus 6 into 0.5 Maho. Okay, that is GMB. So what is my V naught? V naught by V in. Now what is my V naught by V in? That is minus GMB. That means minus 20 into 40 into 0.5 into 10 to the power minus 6 into 1 kilo ohm, 10 to the power 3. So 20, 20, 40 minus 400, 10 to the power minus 3 minus 0.4. You are having minus 0.4. So your answer is V naught by V in is minus 0.4. That was a easy question if you know the concept of this body effect. If you don't know the concept of body effect, this would become an impossible question to attempt in the examination. So that's why I taught this concept that can be asked anytime in the GATE examination. So yeah, I hope you will be able to understand what we did in this problem. We just needed to find the small signal voltage gain. If they are asking about DC gain, that means they are asking about small signal voltage gain only. So you need to find V naught by V in. So all the DC parameters were neglected. So from there we got to know that only one current component is there, that is GMB V in. That's it. No other component is there. So because of that, our gain would be minus GMB V in into 1 kilo ohm. So GMB by GM ratio is given, that is 0.1. So then we found the value of GM, because for that we know the formula. So from there, mu n CUX W by L was given, VGS was also there 0.9, and VT was also given. So from there we go calculate the value of GMB, and then we could find the gain. So that's how we found the gain. That was minus 0.4 volt per volt. So our answer was A. So these kind of questions can be asked anytime in the examination. So try sharing it with your friends so that it reaches the maximum people. Okay, and yeah, that's it. Thank you.